Hello everyone, good evening. This is Shatarupa and welcome to Rasayanika. So this is our 6-day live session for the CSIR NET June 2021 question paper discussion. Okay, so today is our not sixth, I will say that is our last day for this live session, and today I am going to discuss another some question regarding this CSIR NET examination which was happened on 16th February in this year. So before starting, I would like to know from you all that am I audible? Am I audible? If I am audible, then please type in the comment box so that it will be visible to me and I can proceed. Okay, so I think I should wait for 1 and 2 minutes just for someone if they can join. So yeah. I hope this examination was good for you all because this time, if you have seen the question paper, the organic and inorganic question part was very good. Inorganic part was pretty simple. It's almost like straightforward questions, and the organic questions some were very easy and some were conceptual question. But in physical chemistry, I would like to say that some questions were obviously conceptual, and some other questions were like mathematical, and the calculations were somewhat difficult. I would like to say not difficult, but rather than it was lengthy. Okay, for some questions actually. So I think you all given a very good examination from your side. So let's start with our first question for the today discussion class. Okay. Yeah. This is our first question. The question is the maximum number of phases that can be simultaneously in equilibrium for a one component system is. So basically this question was asked from your physical chemistry and from the phase diagram. This time, I would like to say that phase diagram questions were very simple, just like the very straightforward questions, and so many questions like from phase diagram, wherever I can remember that maximum 3 questions they asked this time, and all questions were very easy. We already discussed in our previous session the other questions, and this is the last question regarding this phase diagram in this physical chemistry. Okay. So the question was pretty simple. The question was the maximum number of phases that can be simultaneously in equilibrium for a one component system. So basically you have to say the maximum number of phases that can be in equilibrium for one component system. So the options were 1, 2, 3 and 4. So do you like to answer this question? This was pretty simple question. If you like to answer this question, please type in the chat box or in the comment section so that it will be visible to me and I can say whether it is correct or not. Okay, so Rajupa answered. Yeah, good evening, Rajupa, and you answered the option 2. Okay, so let's see whether it is correct or not. The option 2. No, this is not the correct option. The correct option will be the option 3, that is the maximum number of phases will be 3. So why the maximum number will be 3? So let's jump to our solution. Rajupa again answer the option 4. Okay, so let's see Rajupa, just wait for a minute and I am going to solve this. Okay, so you have been asked in the question, just look upon the question. This is one component system. Okay, so basically the number of component is given in the question, that is 1. Okay, so you know all the phase rule, the basic phase rule, that is how to calculate the degree of freedom, that is F equals to C minus P plus 2. Okay, so here C is given to you, that is 1. Okay, so if C is 1 and plus 2, and you don't know the P, and you have been asked this P actually. Okay, so basically just calculate this. If we put the 1 here and the 2, that means that is 3, that is P minus 3 we get. F equals to P minus 3, right? Now you need to know one thing, that if we put the P value, that is 3, that will going to give us a value like 0. And if we put like 4, P becomes 4. If we put the value, the P equals to 4, then that will give a positive value. Okay. So if we put the value like, it's not P minus 3, it's 3 minus P, right? Yeah, 3 minus P. If you calculate this, you will get 3 minus P. So if we put the value P equals to 3, then we will give, if we put the value P equals to 3, then we will get F equals to 0. Okay. But if we put the value P equals to 4, then we will get minus 1. So basically, it states that degree of freedom becomes minus 1 if we put the P equals to 4, that is the 4 phases will stay in equilibrium. If we say like this, suppose we are saying that all 4 phases can stay in equilibrium. So the degree of freedom will become minus 1. But you need to remember one thing, the degree of freedom cannot be negative value. It can be always positive or 0. Either positive or 0. So the maximum value of P, that is the phases, can be stay in the equilibrium, that is 3. So basically from this logic we can answer this question easily. So the option will be 3. Yes, this option will be the correct option. That is maximum 3 phases can be stayed in the equilibrium. Okay, not 4. And this is the maximum phase, 3. So it's a pretty simple question. So here also I have written this explanation regarding this, that P should be greater than 10. If we put the value P greater than 3, that is 4, then it becomes negative. So it cannot be possible. So the maximum value is 3. Okay. Do you get my point? Understood, everyone? So if yes, I want to move to our next question. Yeah, question number 2. This is another question, the question and from your physical chemistry basically. The question is, liquid A has half the surface tension and twice the density of liquid B at 30 degrees Celsius. Basically, they have been given an information that liquid A has half the surface tension and twice the density of liquid B at 30 degrees Celsius. The contact angles of A and B are the same. Okay, so another information is the contact angle is same for both A and B. And if A rises 10 centimeter in a capillary, then the rise of liquid B in the same capillary at the same temperature will be equal to what? So this is basically a question from your surface tension. This time the CSIR asked about the one question from your surface tension, and it was very conceptual question. It is not difficult. But just you have to apply some conceptual things, you have to apply, you to memorize some basic concepts or formula, then easily you can solve this. Okay, so anyone would like to answer this question? Vasumati? Okay, good evening Vasumati, very good evening to you. So hope you like this session. So if you know the correct option, if you want to answer, please comment in the chat box so that I can proceed. Yeah, so let's move to our solution. How to solve this type of problem? Okay. Yeah, the correct option will be, option 3. Yeah, this 40. How we are getting this solution? So basically we know the surface tension, that means we normally represents it by gamma. So the basic formula for surface tension is gamma equals to half H rho G divided by cos theta. That is basically cos theta means the theta is your contact angle, which is given to in the equation in the information, H is the height, rho is the density, and G is the gravitational constant. Okay. So H, rho, G, and R, and something like I missed this, that is R, that is the cross section or the radius, something like that. Okay. So for the same liquid, for the different liquid, if we use the same capillary, so basically all will be going to cancel out because the liquids are different, the density are different, so and also the height will be different. Actually, the height will be different. Okay. Density different, height will be different, and both the liquids, since the liquids are different, so the surface tension will be different. But all other things will be same because the cos theta, it will be always same because the theta will be same here. The cross section, that is the r here, radius, also will be the same, and G is constant term. Okay, so we can easily cancel this constant term. So for the both A and B liquid, if we take the ratio, basically we will get HA by HB, that is HA by HB. If we get like this, let's take like this, so we will get gamma of A by rho of A into rho of B divided by gamma of B. Okay, so basically just look here, I have already already solved this equation as I have written there. So we are taking this ratio, okay, HA by HB, basically the differences, the ratio for their height. So basically H is going to be like that, H equals to gamma by rho, right? Because all other terms are the constant for both the liquids, so we can easily cancel out those. So HA by HB will be like gamma A by rho A into rho B by gamma B. That is the H equals to gamma by rho. Okay. So just put the value here. Now we know that is in the given equation, gamma A is half of gamma B. That is the surface tension for the first liquid is what? It is half of the second liquid. Okay. And another information is given in the equation, that is rho A equals to 2 rho B. That is the density of the first liquid will be twice of the second liquid. Okay. And also a given that the capillary tube height of the first liquid is 10 centimeter. Okay. So basically put the value and you will get cancel out everything and you will get 1 by 4 HA by HB, as the ratio will become 1 by 4. Now just put the value HB here. Is a pretty simple thing. We are we are going to solve the calculate the value of HB. Okay. So HB will be HA into 4. So 4 into 10, put the value here, you will get 4 centimeter. Okay. So this is a pretty simple thing. So the 40, this will be the correct option, option 3. Okay. I think I am clear to everyone, right? Is it clear to you all? Yeah, if yes, then I want to move to our next question. Yeah, this is our third question. Yeah, this question is another question from your surface tension, not only surface tension, I would like to say from your surface chemistry. It's a pretty simple question and conceptual question, this time asked from the surface tension. So the question is, the surface tension of a dilute soap solution is lower than that of a pure water because of what? Basically, they have given 4 statements and you have to say which is the correct option or which is the correct statement among those. Okay. So the question was, the surface tension of a dilute soap solution is lower. That is, they have already told that the surface tension will be lower in the soap solution. Okay. Than that of pure water. That is, from pure water, than that of pure water, the soap solution has always a surface tension in lower amount. Okay. So they have given some options like number 1 option, soap molecules accumulate more at the surface than in the bulk solution. Okay. Soap molecules accumulate more at the surface than at the bulk solution. Option 2 is soap molecules accumulate more in the bulk of the solution than on the surface. Option 3 is the soap molecules aggregate uniformly in the bulk and the surface. And option 4 is soap molecules form micellar structures at low concentration. Okay, so which will be the correct option? Would you like to answer this question? Let's type in the chat box so that I can say whether it is correct or not. Okay, so let's don't waste our time. So just we need to solve so many equations, right? So just let's see how to solve this question. Okay, so basically the surface tension of dilute soap is lower than a pure water. We already know this. Okay. Pratibha, Pratibha told that option 4 is the correct option. Okay, Pratibha, thank you for your answer. So let's see whether it is correct or not. Okay, so just see our solution and stay till the end. So we are explaining here. Okay. So Pratibha said that soap molecules form micellar structure at low concentration. So what will be the correct option actually? Basically, in this question, the correct option will be the option will be the option 1. The soap molecules accumulate more at the surface than the bulk solution. Because, okay, why this is? Because if we go into our solution, we can understood this. That is the from the Gibbs adsorption isotherm. We all know the Gibbs adsorption isotherm. That is the equation regarding this. This is basically minus C by RT. This is the equation actually basically minus C by RT into del gamma del C at constant temperature. That is the partial derivative of gamma, that surface tension, with respect to concentration at constant temperature. And this is the basically Gibbs adsorption isotherm, what we are going to say here. This is basically the equation. We need to remember everything for this regarding the surface chemistry. So this gamma is represents the surface tension, and what is the C? C basically the concentration. Okay, so basically concentration C is what nothing like that. Gamma is the surface excess actually. This gamma is the surface tension, and this capital gamma is representing the surface excess. So what is going to say, like, what is surface excess? Surface excess means nothing but this. C of surface, that is concentration of the surface, and the concentration minus the current concentration of the bulk. That's basically the capital gamma, that is the surface excess, is represents the concentration on the surface, which is in major amount or in more in amount than the concentration in the bulk solution. Basically the difference between this. Okay, so this is called nothing but the surface excess. So when we actually add the basically the soap or detergents like that in the solution, so what is going to happen? Just see this. Suppose this is a beaker, and here put it here some surfactants aging actants actually, surfactants actually. So what is going to happen? Surfactants basically accumulate, and where? Because basically they accumulate in the surface. Because we all know when they accumulate, they form the micelles. Okay, so micelles have like an hydrophilic polar head groups, and it has a hydrophobic tail. Okay, so the tail is hydrophobic, so they are basically they cannot stand within the bulk solution. Okay, so they eventually they move to shift, or they move to, or they are moving eventually for as far as soon possible. Actually, they are moving to the surface of the liquid. So basically, the tails are moving to the surface. The polar head groups stays inside the liquid, that's in the bulk solution, and the hydrophobic tail comes out to the surface. So basically, the surface acting agents or this detergents or soaps, they basically accumulate over the surface around. Okay, so here the surface excess amount of the, or we can say the concentration of the surface excess amount is here is the in much amount. Okay, so basically C surface concentration of the surface and minus concentration in the bulk solution, we will get a positive value, right? We will get a positive value because this is increasing on the surface. So this is basically, if we want to keep positive this term, here is a minus term, right? So it is always necessary to keep this term as a negative term. Otherwise, it will not cancel each other, and it will not give a gamma value in positive term, right? So just to make it balance, just to balance this equation, just look upon the equation. If here in the equation, also look upon the equation, there already given that the surface tension will be lower. That is, while adding the surfactants or the detergents in the solution, already the surface tension will decrease, eventually decrease. So it is a negative term, right? So to make this term, total as a whole term, in balance, like here is a minus term also. So C by RT times should be positive. This is another proof that the C is going to be positive. And what is this C? C is nothing but the surface excess. That is the concentration of surface minus the concentration in the bulk. Okay. So basically, we will get a positive value. So we can easily say by mathematical, right, from the Gibbs adsorption isotherm, using this, we can easily say that is the above surface, actually the concentration will be high in amount rather than bulk. So here in the option, we can say that the option 1 will be the correct option, not the 2. We can cancel this 2. It's just reverse of this thing. The soap molecules segregate uniformly in the bulk and the surface not uniformly. So it's also cancelled. Soap molecules form micelle structures at low concentration, not in low. It's obviously in high concentration. So it's also cancelled out. So this is what I want to say. Okay, so clear everyone? If clear, I want to move to our next question. Yeah. Our next question is another question from physical chemistry, and this is a pure mathematical calculation actually. The question was asked here, that is, consider an electron. Me is given, that is the mass is given for the electron, having energy is 13.6 electron volt, confined in an infinite potential well. Okay, infinite potential well. If the potential energy inside the well is 0, that is given in the equation, that is inside the well, the potential energy is 0. The expectation value for the square of the electron speed, that is V square average, you need to calculate this V square average. So basically, this question is pretty simple, but still you have to solve this question to calculate this question. So if you follow the every information is given in the question, basically it's nothing but they are talking about a particle in the box. Particle in the box basically. Here there we can see that the potential energy inside the well is 0. And in that case, we can get the expectation value also. So basically, if you move to our solution, we can see potential energy is given here 0. Okay. So the total energy, what is the total energy? We already know the total energy means the kinetic energy plus the potential energy. But here the potential energy is given 0. So here basically the total energy is equivalent to kinetic energy. Okay. Another, we know that why to represent this kinetic energy, this is basically P square by 2m, that is Px in around x-axis actually. So this is nothing but P means it's momentum, that is m into v. Okay, so Px squared by 2m. So if we equate this just like this, we will get a value Px squared equals to 2me equation 1. We can say like this. Okay, so now we need to calculate the average V, that is V square average, that is V square expectation value. This is, so how to calculate this? We already know the given E value, average V, the average value, the energy value is given 13.6 electron volt. Just convert it into the joule, because in the equation if we see that the answer, everything is joule or in meter second, so nothing in electron volt, right? Like this. So just once we can calculate this if we once calculate convert into electron volt into joule or anything else. So then it will be easy for us. So basically 13.6, how to convert in from electron volt to joule? Just multiply with electron its charge, that is 1.6 into 10 to the power minus 19. So just calculate it, you will get this value in joule. Okay. So now basically put there the mv, that is momentum, right? P equals momentum, that is m and to v. So basically here it comes a square, m square into vx square equals to 2me. Okay. So just cancel out this m, 1m, and you will get vx square average. Okay. It is going to be like that, 2e average e by m. This is what we need to calculate this basically. It's a pretty simple thing. So how to calculate this? Just put the value here, 2, and you already calculate this average E value in joule, in terms of joule, and put the value, the M value, the mass of the electron, which is given in the equation in terms of kg. So just calculate it and put the every value. The joule means you already know, meter square second inverse, like that. So just So meter square second to the power minus 2, like that, these things like. Okay, kg meter square second to the power minus 2. So just it will be cancelled down and we will get in terms of like this. Okay, this is a v square actually. So just put all the units here and cancel out. You will easily get this answer, and it's given in the question paper. So basically in this term, I can say that the option 3 will be the correct option, and in this time the calculator, electronic calculator or the digital calculator is given to you. So it can be very easy to calculate you for all these mathematical equations. Okay, you don't need to mug up or to approximate so many things. So it was like this. Understood, everyone? If I am clear, then I would like to move to our next question. Yeah. Yeah, fifth question. This question was asked about some electrochemistry actually. The stopping potential for photoelectrons emitted from a surface illuminated by light of frequency like this. They have given a value of frequency, and the potential, the stopping potential for this is given. What is this? The stopping potential for photoelectrons emitted from a surface illuminated by light of frequency is like that. Frequency is given and also stopping potential is given. What is stopping potential? Stopping potential means the amount of the potential which is applied on the electron just to stop its illumination from the surface. So what is the amount of the potential? It is 0.72 volt is given. When the incident frequency is changed, that is, this frequency is changed, the incident frequency is changed, now they have told in the question. The stopping potential is found to be like that. It is also changed. The new frequency is approximately what? They are actually asking about the new frequency. So would you like to answer this question? This question was from your somewhat in electrochemistry, and we can say from your basic quantum chemistry actually in the just first chapter regarding this. So it was a pretty simple thing, not too much hard actually. So basically they have given the new one value, we can say the stretching frequency one, that is the incident frequency, okay, and also given the E value, that is the potential, stopping potential in case 1, and they also told that in case 2, that is why when the change frequency is changed, it is converted to 1.44 volt. So what is the frequency, second frequency? Okay, so let's see our solution. Yeah, basically they have told about here, that's the work function. We already know work function phi equals to h nu minus E. So what is h nu? H nu is its frequency into the Planck's constant factor, we already know, and minus E means the potential. Here it is given as a stopping potential, ES, okay, and don't forget to multiply with the charge Q, otherwise you will get the value wrong answer, and the you can't actually going to get the correct unit also. Okay, so this is basically our formula, that is work function phi. So for if we change this nu, so again one thing we can see here, that is the frequency is changed, and previously the stopping potential was 0.72 and now it is changed to 1.44. So we can say the value is increased. So basically from the formula you can see that see that is a proportional relation, right? That is, if E is increased, then also should be there, the nu should be also increased. It's a pretty simple thing, right? So that's why we can assume that the second frequency of the incident frequency, that is, it should be in higher region, higher value, or must be greater than this, but not less than this. So you can easily cancel out this value. Second option, you can easily eliminate it. It's a pretty simple thing. Just apply your concept, just look upon your options, just apply your pretty conceptual things, logic, everything, and you can easily go to the options, correct options. So among 1, 3 and 4, now we need to answer. So basically the incident frequency is changed here. So we can say if we equate for both the equations, this is for state 1, suppose it is H1, H nu 1 and ES1, then we can again define the phi, again the work function will be equal, okay. So H nu 2 minus E of S stopping potential 2 into Q, okay. So now equate this both thing, we will have the same work function value. So now if we equate this, we will get this equation H nu 2 minus H nu 1 equals to Q into ES2, that is stopping potential 2 minus stopping potential 1. Now just put the value. We need to find the value of nu 2, that is the changed incident frequency. So how we will get, just H will be coming out here by this, and you will get this Q by H, that is the E by H is given in the question. E by H is given in the question. So Q by H's value is given in the question, just put the value into ES2 minus ES1, that is 1.44 minus 0.72, and also put the value for the Q, these things, everything, and you will get the answer. Easily you will get the answer, and the correct option will be option 1. Yeah, this one. And another thing you don't need to forget, just here it is given in megahertz, okay. Just look carefully. Megahertz means this value into 10 to the power 6. So you have to multiply with 10 to the power 6. Don't forget to use this. Don't forget to use this, because otherwise you will get wrong answer. Okay. Papri also answered. Very well explained, ma'am. Okay. Thank you, Papri. So stay with us till the end. So if I am clear to everyone, I want to move to our next question. So before moving to our next question, I would like to say that we have already started our CSIR NET coaching for the chemical science. And if you want to join with our new batch, just enroll here. So we not have much days actually. We have only started this for 4 or few days before. That is 4th March. We have started this coaching. So goal-oriented teaching methods employed in every class. We are providing read classes by CSIR NET experts. Printed hard copy study materials will be provided to you. Class dates, monthly practice exams will be taken. Unlimited expert assistance and doubt solving via chat. You can do this. We can get this type of help from us. So for more information, please visit and call us on the toll-free number. So here the given the information, the number and the store address. So you can go there and check the link, and you can enroll yourself here. Okay, if you really want to get crack the CSIR NET. Okay, so next move to our next question. So this is for the reaction. This is given. Their reaction is given the cis2 trans for this particular complex, and they have given there is a equilibrium is established among the system, and the forward reaction, the equilibrium, the constant with rate constant is K1, and for the backward reaction the rate constant is K2, that is Kf and Kb, right? They have given Kf and Kb, forward and backward. So the equilibrium constant is given, the total equilibrium constant is given, and the forward rate constant also given here. The experiment is started with pure cis form. The time taken for half the equilibrium amount of the trans isomer is to form is about. So basically they are asking the time for the half the equilibrium amount of trans we get. So basically they are asking about the half, T half. Okay. Basically how that is at what time we will get the half of the equilibrium concentration value for the trans from cis. Okay. So basically they are asking about the T half. So it's pretty simple thing. We can solve this question. So basically, I want to solve this question. So let's see our solution. Our correct option will be option 1. Yeah, this one. So how we will get this? Just let's jump to our solution. So yeah, you're basically given from cis to trans, and you have been given the informations like you have to just write down the data given to you. That is Kf, that is the rate constant for the forward reaction is given. Also the equilibrium constant is given, the overall equilibrium constant. And you know that the overall equilibrium constant, how we represent is K is represented as the ratio of both the rate constants of forward and backward reaction, right? So basically this is the thing. And from this information, you can easily calculate the rate constant for the backward reaction, right? This Kb will be going to be like this, and we will get this value. Yeah, if you calculate the value, then you will get Kb is like that. Okay. So what is the T half now? We already know the T half for the first reaction. We already know 0.693 by K, right? So here what is K? It is basically nothing but the total rate constant, that is the summation of forward reaction rate constant and the backward reaction rate constant. So if we get both the value, just get a summation over this and put the value here, and you will get around 300 seconds. That is, here the most close answer is given, that is 290. Okay. So this is the correct option. Yeah. So am I clear to everyone? If I am clear, I think I am clear to everyone. No any doubts from you. So I would like to move to our next question. Yeah. This is our seventh question. Our seventh question is, this is also regarding your kinetic theory, that is your kinetics, chemical kinetics. Another question, the previous question also asked from your chemical kinetics also, and this question again asked from your chemical kinetics. Okay. So this is the question, this time the question has been pretty simple from chemical kinetics. The rate, the previous question, I would like to say that in previous question only if you know that here the relaxation time is we are going to calculate, or relaxation constant. If you know that, then only you can follow this, because the total K will be the summation of the forward and backward reaction constant. So basically it's nothing but the relaxation constant. Okay. So here the why we are using this relaxation relation, because this type of equilibrium, if you go through the chemical science, chemical kinetics chapter, there you can see that there is a relaxation time is used and relaxation constant is used in during calculation this type of problem. So that's why we added these things and we get to know this. So just if you know this basic concepts, then you can solve these problems easily. Otherwise, it will be difficult to you to reach to the options. Okay. So I was talking about the next question. Yes, Papri. Yes, ma'am. Okay, so you got my answer. You got my explanation. Okay, thank you, Papri, for answering this. Okay, so next question is another question from your chemical kinetics. So the rate constant for the reaction A2B4O is given like this and is described as log K equals to 14.1 minus it's 10,000 Kelvin by T less, something like that. This equation is given, it's a relation is given to you. So now the activation energy for this reaction is they are asking about the activation energy. Okay. So how to solve this question? How to get the actual value for the activation energy? So this is a pretty simple thing, because it's from your Arrhenius equation. If you know the chemical kinetics, if you already did this, so it's a pretty simple thing. You should know that the Arrhenius equation. The Arrhenius equation is rate constant K equals to capital A, that is pre-exponential factor, into exponential to the power RT, right? It's line to line like this. I can't read here. Yeah, that's like it. E to the power minus epsilon by RT. It's looking to this. Yes, it's look like this. So basically here the epsilon value, this is the energy value, this is the activation energy, and you have been given a relation in terms of log, right? So just take log in the both sides. So ln K equals to ln A minus epsilon by RT. And if we convert it into log K, just you will get this value. The RT in the below value, that's 2.303 direct. You know this conversion, I know from your from 11th 12th standard. So basically we are nothing, we are utilize this simple thing, how to convert from log value to log value. Okay. So if we compare this equation to our given equation in the question, you will get that this value is given, right? This term. What is this term? Yeah, this term is this in this equation, right? So just compare this and cancel out everything and you will get epsilon value, that is the activation energy value. If we calculate this, you will get the activation energy value. And you will get the option 1, the correct option, that is 191.4. It will be the correct option if you calculate everything. So you will get the correct option 191.4. So it is the correct option, the option 1. Okay. So am I clear to everyone? Clear, right? Okay, so if I am clear, moving to our next question. Yeah, this is our 8th question. The question is regarding some electrochemical equation, actually electrochemistry. So this time electrochemistry equation was also simple, but I would like to say the calculation was somewhat time taking for sometimes. So if you, very slowly, if you with your calm mind, if you really solve these questions, you can easily get your answers. Okay, you will not face any difficulty. So the question was for the cell, that is they're given a cell. This is the question actually. Yeah. Okay. So here the given that E0 value, that potential is given, and also the dE0 by dt, that is the temperature coefficient, is given here, and also temperature is given 27 degree Celsius, and the delta H, that is the enthalpy change, the value or for the reaction CD, this reaction actually, for this the delta H or the change of enthalpy actually they have asked you. So you need to calculate the delta H regarding this cell or this electrochemical reaction. So how to solve this question? Anyone would like to answer this question among you? If you would like to answer this question, please type in the chat box. Okay, so let's move to our solution. Yeah, the correct option will be option 1. This. And how we are getting this answer? It's a pretty simple thing. So just slowly, if you solve this, you will get to your correct option. Okay. So here we need to calculate the delta H, the enthalpy basically. So we already know a basic thing for solving any kind of solution, that is delta G equals to, this is a basic equation, delta equals to delta H minus T delta S, right? Okay. So for the electrochemistry for this particular cell, we all know what is the formula of delta G, that is Gibbs equation. This is Gibbs-Helmholtz equation, right? So what is the Gibbs equation? What the formula of Gibbs energy? So we can say minus NFE. Okay. So delta G in terms of, we replace it with NFE value, where the N is the number of electrons transfer, F is the Faraday, and E is the potential. Okay. So E0 value basically. And equals to delta H we have to calculate and put the value here T into delta S. And what is delta S? We already know these things. Delta S is nothing but minus and derivative of delta G with respect to delta T at constant pressure. Right? Delta delta at constant period is like this. This is a negative derivation of this. This is going to, this is nothing but our delta S, this change of entropy. So we can easily put the value here like minus del G by del T at constant P. And now you have to put the value G here, that is minus NFE. And again differentiate it, you will get a particular value. So if I am not going to solve everything here, just I am saying this keywords here. So if we solve this, is do the differentiation over this and taking common the NF part from both sides, the rearrange this equation, then you will get this value. Yeah, delta H will be equal to like this. Okay. So now it is easy for you to calculate. Now put the value N is 2 here. That's 2 electron is transformed because the equation is like this. 2Ag plus 2 CdCl2 like this. So Ag plus this charge is 2. Okay, total charge is 2. That is the 2 electron system transferred. So 2 into in the Faraday value, that is 96500 coulomb mole inverse. And all the things value, T value is 300 Kelvin, and all the things, that is temperature coefficient is given here. Yes, temperature coefficient is given here. Yeah, this value. So put this value, everything, and calculate, you will get approximately minus 168 like this. Okay. So this is the correct option. Option A. Am I clear to everyone? The calculation was sometimes it's lengthy because you have to derive something. If you remember, one thing I want to say, if you remember this particular equation, if you can remember, then it is very, very easy for you to calculate. But sometimes this type of large mathematical type formulas or something, we cannot remember, right? So we need to first derive those, then put the value there, and it will be easy for us. So if you have a very good practice in your hand, so it will not take just 30 seconds to 40 seconds to get this value, or hardly 1 minute, then you can easily get the value. Okay. So if I am clear to everyone, then I would like to move to our ninth question. Yeah, this question is a sample from your polymer chemistry actually. The sample of polystyrene is composed of 3 weight fractions that is given this value, and the molecular weight of these fractions are also given respectively. The weight average molecular weight of this sample is what? So actually they are asking about weight average molecular weight. They have given the weight fractions, they have given the molecular weights. So they have asked here average molecular weight. So how to calculate? If you know the polymer chemistry and some basic formulas for the polymer chemistry which are very, very important. So if you should know this formula actually. That is average molecular weight will be like the MW average equals to summation of Ni square divided by summation of Ni Mi. That is, Ni means the number of fractions for whatever here it is used, and Mi means the for the molecular weights, and take the square term for this and add get the summation value for all the things and divide it by summation of Ni Mi. So just follow this rule, this formula, and put the value here. You have given n is for the first term is 0.20 into the m value, the first molecular weight. Just look upon our question and you will get like this, and 10,000 like this, right? So just put the value here and add those, and above in the denominator and the numerator also you can put those, and you will get your answer. So correct option will be, you will get like this, approximately around 40,000. So the option A will be the correct option. It was a pretty simple question and is a very straightforward. If you know the formula, then you can calculate it easily. Otherwise, it will be difficult for you to calculate this. Okay. So I think it is clear to you. Now I would like to move to our next question, that is 10th question. Yeah. This question is from your solid state chemistry, I would like to say. So basically the question is, question was asked here. This time this solid state chemistry is slightly difficult because I would like to say here a term that is a is for monoclinic lattice is used here, not normal lattice or in normal FCC, normally normal BCC type of simple cubic lattice. Not they are using like simple cubic lattice. The monoclinic lattice is used here. So if you know about this monoclinic lattice, that is what type of lattice is this? What will be the angle? What will be what will be their sides, the sides of the edges? What will be the length of the edges? If you have any basic idea how it is look like, so then you can easily answer this question or calculate this. Otherwise, it will be difficult for you. So a very basic question actually. You need to know these things if you really want to solve the physical chemistry questions. And also already solid state is an independent and also a different and it's easy chapter actually. So the question was asked here: the plutonium, that is atomic mass, is given, the crystallizes in monoclinic lattice. Okay. So and also they have given the ages. A is 620 picometer, B is 480 picometer, and C is 1100 picometer. And also they have given the beta angle, that is the what angle they have inclined actually. So beta is 102 degree. And with 16 atoms per unit cell, so basically they have asked here 16 means they have given the information about Z, that is effective atomic number, that is given 16. The density in gram centimeter cube per cube will be close to what? They've also given the sign value of this. So what will be the correct option? So if we really want to find the solution, we get to know the basic things, that is monoclinic. What is this lattice? This type of lattice actually, the thing that type of structure is for this lattice is where the all the edges are different from each other, no equality among them, that is A not equals to B not equals to C there. And the next thing is the angle between those, actually, for the side angles, among those are already the angles for the this lattice. The alpha angle, alpha equals to gamma, it always equal to, and always equal to 90 degree, but not equal to beta, and beta should not be equal to 90. You need to remember these things. If you know these basic things, then you can use this for any formula for this particular particular solution. So we already know for this, that is Z is given here, A, B and C is given in the term of picometer. So convert it into the meter. So how to convert? Just multiply with 10 to the power minus 12. Just convert it into meter. Just do these things and use this formula to calculate the density. Is a basic formula, you should know this, that is D equals to Z into M. M is the molecular weight divided by N Avogadro number into the volume. Here for monoclinic substance, the volume will be A into B into C into sine beta. You should not multiply with the sine value, sine beta value, the angle value, okay? So if you know this formula, then it will be easy for you. Just put the value, everything here, A, B, C, and Avogadro, aim it, everything is given here. Sine beta also given here. And at last, you have to convert the total unit into the CGS unit in grams per centimeter cube. So you will get the answer 4, that is the option 4. This is the correct option if you calculate this. Someone German Moreno, something commented there, but I can't read this comment. So, okay, so if you get this solution, I would like to move to our next question. Okay, it is pretty simple, right? It's a basic concept from your solid state chemistry, actually. So if you got my point, then I would like to move to our next question. Yeah. Our next question is from your inorganic chemistry, basically, and it is a very straightforward question from your basic group chemistry. Okay, just your basic elemental group chemistry. So the question asked there, consider the following statements. They have given some statements, and you have to answer whether one or more than one options or statements are correct. Okay, so basically the statements were PbCl2 has low solubility in water. Number 2 is sulfides of arsenic 3 and antimony 3 are soluble in ammonium sulfide. Number C is SNS is soluble in yellow ammonium sulfide, and option D is MnS manganese sulfide is precipitated by passing H2S through acidic manganese chloride. Which are the correct statements? Okay. So if we want to solve this question, it will be a pretty simple question. So basically the thing is, we need to know for the first, consider the option 1. Okay, so PbCl2 has low solubility in water. It is correct or not? Yes, it is correct. This option is correct. PbCl2 is low solubility in water. Why? Because PbCl2, if you see that PbCl2 has, it's an ionic compound, right? So though both has large size, in they also the perfect sizes which are matched to each other. Okay. So for PbCl2, the bonding, that is the ionic bonding between the Pb and Cl bond, this is a very strong. Why this is strong? Because this follows the basic things to form an ionic bond, the EOS criteria. That is energy, overlap, and symmetry. Everything is matched for both lead and chloride here. Okay. So basically the bond is very strong. So that's why. So it has a low solubility in water. So we need to heat or need to any another force just to make it soluble in solution. Otherwise, it will not show solubility in the solution. So it's a very low solubility in water. This is a correct thing. Number 2 is sulfides of arsenic 3 and antimony 3 are soluble in ammonium sulfide. So if we see our solution, that the reactions basically for arsenic 3 and antimony 3, that is basically talking about these equations, these inorganic salts, actually H2S3. So if we add the ammonium sulfide, we will get this thiosalt actually, and which is soluble in ammonium sulfide. Actually, this is soluble. And the next thing is, if we antimony 3 is used, that is the salt of where the antimony 3 is the oxidation state here 3. So if we react with the ammonium sulfide, we get this thioantimonate. Okay, this is basically soluble. This is basically soluble, ammonium soluble. It is soluble thing actually. So again, for these things we can You can say like this. And in the third survey, so the B, option B is also correct, statement B. And the C, statement C is SNS is soluble in yellow ammonium sulfide. So if we see the reaction, that's a tin sulfide. SN means a tin sulfide. It is also soluble, because it will give such kind of reactions, and it will give us such product, ammonium tin sulfide. Okay, so this type of thing is like this. Thiostanate. We can say this, the thiostanate, and this is very soluble in the solution. So this is another thing which is also right. So this statement C is also right. So our correct statements will be option A, that is A, B, C. 3 are the right, but not the D. D is the incorrect statement, because manganese sulfide is precipitated by passing H2S through acidic amine solution is not correct. It is incorrect statement. So our correct statements will be A, B, and C. So the option A will be correct. So am I clear to everyone? If I am clear, I would like to move to our next question. This is our last question for this live session also, and also for this all the through 1 week live session, also the last question. So this is the question, another question from you, inorganic chemistry, and basically from your mechanism, inorganic reaction mechanism, where we study this thing, some coordination chemistry. Okay, so the question was a very interesting question this time asked. So consider the following statements for the self-extends electron transfer. So here it is given for the reaction chromium water H2O whole 6 is the complex is given 2 plus to 3 plus, where that is the chromium oxidation state is here 2 plus in starting, and after that is changed to 3 plus. So what are the correct option here? So basically if we see the chromium 2 plus and 3 plus means basically chromium 2 plus and chromium 3 plus, right? So this is basically 2 plus means it's D4 system and 3 plus means it's D5 system. So if we just write down or draw the basic d orbital splitting, how they have split it, T2G and EG. So we will get for D4 system like this 1, 2, 3 electrons, and here in EG orbital is 1 electron. And for the chromium 3 plus, it is D3 system, right? So only in the T2G orbital we can see the 3 electrons, not in the EG orbital. Okay, this is blank. So here basically the electron is transferred from 2 plus to 3 plus. That is basically electron is transferred from this EG orbital to this EG orbital. Okay, so basically this EG orbital is nothing but sigma star. So maybe students are confused with this term, that is sigma star, but it's nothing but EG orbital, because it is anti-bonding orbital, and here this is transferred from this to this. So basically it is involved the electron transfer from sigma star to this. So it's pretty simple things. This statement is right. Another option statement is option B, statement B, that is it involves large inner sphere recognition. So if we consider these things, if we can look upon our question, that is the self-exchange electron transfer. In the self-exchange electron transfer, that is basically a redox, self-redox reaction. Okay. So for this thing already, this from sigma star to sigma star, the electron transfer is going to happen. So what is going to happen there? Thus, just transferring from antibonding to antibonding orbital. So the size of Cr2 plus now getting reduced. Cr2 plus at first becomes larger than Cr3 plus, right? It's a D4 system. And now if the electron is moved from this to this, so now the size of the Cr2 plus is already reduced, and now it is becomes very comparable to Cr3 plus. So that's why there are also and self electron reorganization is occurs. Okay, this is within this complex, and this is completely inner sphere electron reorganization. Basically, this is self-exchange is basically outer sphere mechanism. This follows, but in this particular step here, after sharing the electron from the sigma star to sigma star, that's anti-bonding orbital, the size is reduced for the chromium 2 plus, and it is moreover equivalent to this chromium 3 plus, and that's why the electronic reorganization is occurring there. And this is intermolecular, right? Inner sphere reorganization. So basically this is the correct option also. And it involves no change in metal bond ligands. It's wrong, because it obviously it involves the change of metal ligand bond distance, because when the electrons is transferred, then it is already the metal ligand bond length will be stretched, it increased. So here it is the wrong thing. And the D is the rate of self-change electron transfer is fast. No, not fast, it is slow, because the electron is transferred from the antibonding orbital to antibonding sigma star, right? So it's obviously an unstable state. The electron is transferred from an unstable state. So basically it's a very slow reaction. Okay, it's not a very easy case. So it will be fast, not fast, it should be slow. So option D, the statement D also be wrong answer. So the correct option will be, statements will be A and B. So the correct option actually A and B means the option B. Yeah, this is our correct option, option B. And basically this explanation is I have written here, which I have explained here. Okay. I think it is clear to you, right? Clear to you right now. Okay, option B is the correct option. The option A and B will be correct option. A and B. Clear, everyone? So if I am clear, so I would like to say the today's session I would like to end here because we have already discussed all the chemistry questions regarding this CSIR NET examination and this time which I had asked you in this question in 16 September, in 16 February. Okay, so again we will again come with new chapters, new topics again somewhere. Okay, so till then I will have to say thank you everyone for staying with us till then, and just all the best for you, and thank you.